Polygons in the coordinate plane. The purpose of this lesson is to use the distance formula, midpoint formula, and slope formulas to classify a quadrilateral. So the formulas. We have the distance formula. The distance formula is read as the square root of the difference of the x's squared plus the difference of the y's squared. Now in class I've been using a different version. The version I've been using, is the square root of rise squared plus run squared. The reason why I'm using this is because when you find the distance of any slanted line, what you're really finding is the height and length of a triangle. Think about this as Pythagorean theorem, that idea of a squared plus b squared equals c squared. So the question that I would ask is, how do you undo a square? Well, you do it by square rooting, so it gets rid of the squared here. Well, the a is really your rise, and the b is really your run. So the reason where these x2 and x1 comes from, it's the idea of taking this x minus this x in order to get the length of the run, which we've just called run. As you notice here, as x2 minus x1, we've called run. The idea of the y2 minus y1 is saying taking this point and subtracting gives you the height, as it's mentioned here. So there's our rise. So what I'm trying to do by changing the formula into rise squared plus run squared is that you're already good at finding slope. You've been finding slope for many years. So if we can piggyback on information that you know, it can take a formula that looks rather complicated and kind of cut that down. So the distance formula is used to determine whether sides are congruent because you're finding the lengths of sides, or whether the diagonals are congruent by finding the lengths of the diagonals. Midpoint formula is the idea of taking average. When we find average, we add everything up and divide by how many there are. Well, in a particular line, you have one x and a second x. So we add them up, and because there are two things, we're dividing by 2. There'd be a y point and another y point, so we add them up and divide by 2. The midpoint is used to find the midpoint of the side, or whether the diagonals bisect each other, they'd have the exact same midpoint. Think about if you had a diagonal come through and another diagonal come through. If they had the same midpoint, they'd be bisecting each other. And lastly, the idea of slope is rise over run. We use it to determine if sides are parallel. They have the same slope. If diagonals are perpendicular, their slopes are opposite, reciprocals. Opposite meaning one positive, one negative. Reciprocal is flipping that fraction upside down. Or whether sides are perpendicular, which is also opposite reciprocal. All right, first problem. It says, what type of quadrilateral is W, X, Y, and Z? So I'm going to make this a little bit bigger to make this easier for myself. Whoops, or not. We'll just leave it. So my tips: graph the points that you have. Then ask yourself, what shape do I think it is? What do I need to prove in order to really show that this shape is what I think it is? And then how am I going to do it? What formulas are we going to use? So start by graphing. Point W is 1, 2, 3, 1, 2, 3, 4, 5. And I would make sure to label 1, 2, 3, 4, 5, 6, 7, 5, 6. And let's see, 6, 2, 1, 2, 3, 4, 5, 6, 1, 2. And then Z is 2, 1. So here is my quadrilateral. I'm sure a ruler would have made my life way easier, but there you have it. So I'm graph the points. What shape do we think it is? Well, it looks like either a rhombus or a parallelogram. I'm going to check first to see if it's a rhombus. What do I need to prove? Well, if it's a rhombus, then all the sides will be congruent, but the sides aren't perpendicular, meaning they're not going to form 90-degree angles. So what two things do I need? I need distance, and I'm going to need to find slope. So one of the things that I'm going to do to kind of help organize my work is I'm going to make myself a table. I'm going to talk about WX. I'm going to talk about side length XY. I'm going to talk about side length YZ and side length WZ. And I'm going to find the distance of all of them, and I'm going to find the slope of all of them. So this can help organize my work. So the distance from WX, I'm going to use the idea of rise squared plus run squared. It looks like I am rising 1, running 1, 2, 3, 4. 1 squared plus 4 squared is equal to, well, 1 squared is 1, 4 squared is 16, so the square root of 17, and I'm going to leave it. I'm going to do the next one. I'm rising 1, 2, 3, 4, running 1. 4 squared plus 1 squared is the square root of 17 again. And the next one, up 1, 1, 2, 3, 4, rise squared plus run squared, again the square root of 17, and WZ, 1, 2, 3, 4, rise 4, run 1. So far, it looks like we're doing okay with it thinking that it's a rhombus because all the sides are congruent. If by chance we would have found that all the sides weren't congruent, then maybe it could have been a parallelogram, but I think that's out here. We can't stop with just finding that the sides are all congruent because it could be a square. Looking at it, of course it's not a square, but let's prove that it's not a square. We can prove that it's not a square by finding slope because these corners will not be 90 degrees, meaning their sides won't have opposite reciprocal slopes. So the slope of WZ was up 1 over 4. The slope of XY was up 4 over 1. This was 1/4, and this was up 4 over 1. Notice these are not opposite reciprocals. So we have sides that are all congruent, but our sides are not perpendicular, so it must be a rhombus. What we're doing here is we're justifying our answer. We're not saying it's a rhombus because it looks like all the sides are congruent. We're not saying it's a rhombus because it looks like the side or the corners aren't 90 degrees. We're actually using these formulas to prove it. Prove that KLMN is not a rhombus. All right, so let's graph these points. K, negative 1, 1. Oh, I think this one's really tiny. 0, 2, M, N. So we're proving that it's not a rhombus. Well, if it's not a rhombus, let's talk about what a rhombus is. So thinking about the properties of a rhombus has all sides congruent. The rhombus has opposite sides parallel. The rhombus has, let's see, what are some other key features of a rhombus? Oh, the diagonals are not congruent in a rhombus. I think this is going to be the key here, because if we can prove that the diagonals are congruent, then it's not going to be a rhombus. So let's look at this. We talk about proving that the diagonals are congruent. The length of the diagonal is LN. The length of the other diagonal would be KM. Well, this one actually is not too bad. These distances that you're looking at are horizontal. The length of LN is 2. The length of KM is 2. So the fact that these diagonals are congruent, this shape can't be a rectangle or a rhombus. I would assume that it's a square. The idea that squares are rhombuses, but not all rhombuses are squares. So it's not asking what the shape is, but it's definitely not a rhombus because rhombuses have diagonals that aren't congruent, and this one has diagonals that are congruent. And then the next one, it's asking for you to prove that it's a kite. So we have point K, 1, 2, 3, 4, 5, 6, 7, point L. If that was 7, this is 8, 1, 2, 3, 4. And 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So here's my shape. Sure looks like a kite. Well, what do we know about a kite? Kite has two pairs of adjacent sides congruent. So if I can prove that NM is congruent to ML, and if I can prove that KN is congruent to KL, then I've indeed proven that this is a kite. So what formulas are we going to need? It looks like I'm going to need distance formula. So let's find the length from M to N using distance formula. I like the idea of rise 1, 2, so rise 1 squared plus 1, 2, 3. So this is going to give me 1 plus 3 squared. 3 squared is 9, so it's going to give me 10. Now let's find ML. I'm rising 1, 2, 3, running 1, also 10. So I've proven that these sides are congruent. So far, so good. Now let's look at KN. Starting at K and going 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5 squared plus 5 squared. 5 squared is 25. 5 squared is 25. Those two together are 50. Now check KL. Rise 1. And then 1, 2, 3, 4, 5, 6, 7. So far, what we've seen is we've seen that when things are congruent, the numbers are identical. But look at this. 1 squared is 1. 7 squared is 49. When I add the two together, we get 50. So I've proven that these sides are congruent. So yeah, it's got to be a kite because I've proven that there are two pairs of adjacent sides congruent. That concludes today's video. I know that all the problems are going to look slightly different, but what you're looking at or looking for is recognizing what shape you might have, recognizing what your properties are, and then trying to prove those properties. Good luck. Please let me know if you have any questions.